ওকে, তো স্লাইডটা দেখা যাচ্ছে আশা করা যায়, সবাই দেখতে পাচ্ছ তো স্লাইড?
Yes.
Okay. So today we'll discuss about MOT, molecular orbital theory. Very important topic. So what are the important features? I just briefly discuss about that important features of MOT. Because sometimes there are MC question where is written important features, some points. Okay. So first, that we know that two atoms combine to form a molecule. Similarly, atomic orbitals, two atomic orbitals combine to produce two molecular orbital. One is anti-bonding MO, another one is bonding MO with low energy. Bonding MO have low energy, anti-bonding MO have high energy. So this is the first feature. That means the number of AOs combined equals to number of MO is formed. Both are equal. Okay. So now question next. The which important features for the MO formation? So there are some concepts that linear combination of atomic orbital. Before go to the linear combination of atomic orbital, we just discuss what should be the characteristics of atomic orbitals. So atomic orbitals should have comparable energy. Okay, comparable energy, comparable shape, and same symmetry. These are the three main features. That means the combining atomic orbital which will combine to form bonding MO or anti-bonding MO, that must have comparable energy, comparable shape, and same symmetry. Comparable energy means degenerate orbital. Okay, degenerate orbital. Okay. Third point is also important. The valence electron of the combining atoms when form their MO, during the filling up of electrons, they follow the above principle, Hornstone and Pauli's exclusion principle. So during the filling up of electrons in MOs, they follow or it follow Pauli's exclusion principle, Horn's rule, and above principle. We know that three principle. That Pauli's exclusion principle means that no two electrons have same quantum numbers. That means if one electron is occupied in the clockwise direction, then another electron must be occupied in the anti-clockwise direction in the same cell or same orbital. Horn's rule means during the filling up of electron first occupied half field or single field and then full field. And above principle shows that lower energy orbital filled up first and then higher energy orbital gradually. So these three orbitals should be mentioned. Okay. And another was the symmetry concept. Symmetry concept we just represent plus minus or something like that. Now, so bonding MO results the symmetry of the wave function or sign of the wave function should be in the same phase, and anti-bonding should be the different phase. So now there is a concept that LCAO, which I want to discuss about the linear combination of atomic orbital, LCAO. Where two wave functions, we know that from the Heisenberg uncertainty principle, it is observed that first concept about the orbital is given by Heisenberg. Because before that, according to Bohr's theory, there is no existence of orbital. There is only orbit, K, L, M, N, etc. But when Heisenberg uncertainty principle is come, that there is a probability of finding electron is defined by the orbital, and then he explained the orbital as the wave function, that is psi. Okay. So now bonding MO are called psi B or normal psi is called bonding MO. Okay. And anti-bonding MO is defined as psi A or psi star is defined as the anti-bonding MO according to LCAO. Okay. Anti-bonding MO. And linear combination atomic orbital told that I just give some brief introduction about that. That psi bonding equals to n into psi A plus lambda into psi B. That theory we know, where n is the normalizing constant, the normalized constant, whereas lambda is the mixing coefficient. Now question, what are psi A and psi B? Psi A and psi B are the wave function of A and B atom. Psi and psi B are the wave functions of A and B atom, which combine to form AB molecule of A and B atom. That means psi A, psi B are the atomic orbital. Okay. So when it is bonding MO, then it is this equation. But if it is anti-bonding MO, then what is will be the equation? On that time, we can write that psi star equals to n into psi A plus minus lambda into psi B. That means n into psi A minus lambda psi B. Here is the lambda is the mixing coefficient, because when anti-bonding MO is formed, when the wave function sign of the wave function is different. If psi A is like positive sign plus another psi A, it form bonding MO. That means psi B. But when it is psi A, but another is negative, that is psi B, then it form psi star. That means symmetry is different. On the type it is formed. Okay. So lambda defined. So we can say that lambda also measure of the ionic character of the bond between A and B. Because lambda defined its bond is ionic or covalent. That is different story. But one thing is that we know that for homonuclear diatomic molecule, lambda equals to 1. It is already proved. And for hydrogen-like atom, for H-like atom, means one electron species like atom, generally we can consider n equal to also 1 normalizing constant. We can consider. Then we can write psi bonding equals to psi A plus psi B, and psi anti-bonding equals to psi A minus psi B. So this concept is called linear combination of atomic orbital. So in most cases, MO is formed when normalized constant is 1, otherwise it cannot form. Because we know that, so if you go to the eigenvalue and eigenfunction in the atomic structure, then we know that 0 to infinity, to find out the electron in the position psi to psi star into d tau equals to 1, that we know. Or we can write 0 to infinity area, we can say psi square d tau equals to 1. Where psi d tau is known as the probability of finding electron in the volume d tau. So psi square d tau has the meaning probability of finding electron in the volume d tau. That we know. Atomic structure chapter. So if the M is the normalizing constant, which measures that the probability of finding electron in the MO is unity. That means unity means we must find out the electron. It is not a zero value. Unity means we must should find out the electron. So this is the basic algebra or basic mathematics for the formation of linear combination of atomic orbital. This is the basic part. There are so many parts are there. So now we try to show how the MOs are formed, which is very important because sometimes MCQ questions are there. Then they asked which is the correct MO for the bonding and correct MO for anti-bonding. So now formation of bonding and anti-bonding MO. Okay. So we know that psi and psi b. So what we have done, we know that if this is a diagram, just we try to plot it. We know that radial probability distribution function or radial probability distribution curve, which I obtained from the eigenvalue and eigenfunction for the atomic structure chapter. So this is the radius r, and this is the nucleus 0, and this is the potential energy diagram. And then we can consider that two atomic orbitals combine to form two molecular orbitals. Okay? So it is one atomic orbital for a atom. Okay, so this we can say like psi a, and another molecular orbital may be like this. That is wave function actually. So it is psi b for b atom. Okay, they combine together to form psi a and psi b. Okay, so for homonuclear atom, you can consider that psi a equals to Ha. What you have one or OA, oxygen or something like that. Psi b equal to Hb, two atoms combined to form H2 molecules. You can consider. Now, when the combination takes place, then they form bonding MO. So, what should be the bonding MO looks like? Now, that two wave function combine together to form a bonding MO. So, how the bonding MO looks like? It is the intensity of this graph, and this is the radius r. It is the intensity of the overlapping zone. Then we can show that bonding MO should be like that way, because this is for A and B linearly combined. B. So this diagram or this graph is called psi bonding equals to psi plus psi b. Okay. In another way, what should be the anti-bonding MO? Anti-bonding MO means one is one lobe, another is different lobe. So this is the bonding. Anti-bonding should be like that way. If this is wave function is this, and this wave function is like that. So if this is psi star, then we can say psi star equal to psi a minus psi b, because both have symmetry difference. And this is the node. You see node. So this is the anti-bonding MO. So this is the bonding MO, and this one is the anti-bonding MO. Okay. Now question, we all know that psi has no meaning. In the atomic structure chapter, we know that psi has no meaning, psi square has the meaning. Okay. So now what can we do? So you need to put out the, because you see in psi there is no problem, all are positive integer. But in the psi star, we see that positive as well as negative. So negative part, how can we measure? We cannot measure. That's why we need to form psi square, not like psi. Okay. So if it is like psi, then we need to prove psi square. If we go to the psi square, then you can see psi bonding square equal to psi a square plus psi b square plus 2 psi a psi b. And another way you can say psi star square equal to psi a square plus psi b square minus 2 psi a psi b. Now what is the difference? Different is only that area. Plus 2 psi a psi b minus 2 psi a psi. This is the only different area for the bonding and anti-bonding. So now if you plot the graph according to psi square value, then what can we observe? Very interesting. This is the basic theory. want to enter. Let's we come to the value of psi square. That is, we square it. When we make it square, then what we found? We found that the intensity should gradually increase like that. This is the A and this is B. Now this is called psi of bonding square. That is psi A square plus psi B square plus 2 psi A psi B. And similarly, if you go to the anti-bonding, so this is the bonding MO. Bonding MO. If we come to the anti-bonding MO, then what is? So negative, if we make some square derivative of the negative, then it will go to the positive. So how it looks like this, because there is a node. Because if we see the anti-bonding, so it, negative part become positive, but there should be a node. There must be a node. So this is the psi star square equal to psi A square plus psi B square minus 2 psi A psi B. Okay. So this is the probability function of anti-bonding orbital. Psi star square is the probability function of the anti-bonding orbital. Now what we have observed that psi A 2 psi A psi B is the main determined factor whether it will be bonding or anti-bonding. That is 2 psi A psi B term. It is defined whether it is bonding or anti. If 2 psi A psi B is positive, then you can say bonding. If it is negative, then you can say anti-bonding. That means 2 psi A psi B is called overlap integral. Okay. So the integral part, so the integral like psi A psi B into dr with respect to radius dr is known as overlap integral. Now I can tell that you have to remember all this graph, because sometimes in the question they ask which is the correct graph for this bonding or anti-bonding like that. So you have to remember. And overlap integral is represented by capital S. Okay. And from that, what we obtain, there is a rigorous calculation, but I do not go to the rigorous calculation. But we have to remember what is the bonding normalizing constant. NB square equals to, you know that 1y 2 plus 2s, where s is the integral. Now NB equal to root over of 1 by 2 plus 2s. Who appear the net exam, he must look at that question. This is one MCQ question. What is the normalizing constant for bonding orbital? So that should be root over 1 by 2 plus 2s. Similarly, so in the net exam they ask this question. Similarly, we can say anti-bonding orbital normalizing constant is root over of 1 by 2 minus 2s. Similarly, and then from the overlap integral data, what we obtain, this is also very important. Something what I have written here, you have to remember psi b, because if you put the value of na, then we get 1 by root 2 psi f plus psi b, and psi a equals to 1 by root 2 psi a minus psi b. So these questions are sometimes asked in the MCQ part. So you have to remember this equation. But how we get this now from the rigorous calculation? But that's part we do not need for the MCQ exam. You have to just remember this. So S, what is the S? S serves as the criteria for bonding, anti-bonding, and non-bonding. Why? Because we know that S is called overlap integral. So how it is possible? I just show you. it is generally importance of S. If for bonding S greater than 0, for anti-bonding S less than 0, and for non-bonding S equals to 0. That means S is a factor which can define whether it is bonding, anti-bonding or non-bonding. This is one part of the theory. Next part is the symmetry. We all know about the symmetry, and from the symmetry what we take two things. One is gerade for G and another one is ungerade U. G and U refer to the orbital about its center or not. Okay, this refers orbital about its center or not. Center. Okay. So how can we proceed about the G and U when gerade, when ungerade? When two F functions combine together and then their electron density resides on the nuclear axis, joining axis, then it is called G symmetry, or sometimes it is called psi G and psi U. So these are the two terms. So now I just show some pictures how a bonding and anti-bonding MO derive. Suppose for hydrogen atom, okay, hydrogen molecule, H2 molecule. So this is, you see that energy profile diagram. This is the distance between two atoms, distance, and this is the potential energy, okay, E. This is the positive part of the wave function, this is the negative, okay, part of the wave function. Now from the potential diagram, suppose HA and HB are the two atoms combined to produce a molecule, H2 molecule. Now if we write, so HA has 1s orbital, this is also 1s orbital. Now this 1s orbital combined, suppose this positive, this positive. So these positive are not the sign, you have to remember it. These are the not any sign. This is the representation of symmetry. So they overlap. This is, if this is the internuclear axis, so they overlap each other. So it is the overlapping zone plus plus, and then show the electron density around the internuclear axis. So this is the MO. MO is formed, positive MO. So it is called psi G because there is a symmetry maintained around the nuclear axis about its center. But when suppose A plus hydrogen atom, another is minus, communicate together, so they try to overlap each other, plus minus. What will happen we don't know, but try to overlap. Then what will form? We will see one lobe towards that side, another lobe towards that side. So there is a nodal plane. Okay, so this is a node or nodal plane. So it is called psi U. Okay, so anti-bonding MO, psi U ungerade, because there is no electron density between the nuclear axis. Okay. So if we represent in the graph, then what we observe? We observe that this is the bonding. So it is psi G, gerade, electron density distributed throughout the area, and one is the ungerade. That means there is no, this is psi U. So this graph we have to revert. This is the potential energy diagram for H2 molecule. So this is bonding, this is anti-bonding. Similarly, SP mixing also possible here, PP mixing also possible here. So you have to remember, I just simplify it, that SS, remember it, SP, PP, sigma bonding, MOs are psi G, means gerade symmetry, gerade symmetry. Okay, sorry. PP sigma bonding, gerade symmetry. But SS, SP and PP sigma anti-bonding MO are ungerade symmetry, psi U. You have to remember it. We do not go to the plot. So all the sigma bonding like SS, SP, PP all are Gerardic and anti-bonding are ungeradic. That is general norm. And that second one is that second one is that P, PP, if we can put a star, then you can say PP pi bonding MO is psi U or ungeradic. And PP pi anti-bonding MO psi G or Gerardic. So in for pi orbital interaction, there is the reverse phenomena takes place. Bonding is ungeradic and anti-bonding is geradic. That you have to remember. We do not go to the detailed study. Now, what are the importance of hemodiagram? Now, come to the question importance of hemo theory. First importance is that what we get information. First information we can know the bond order. Okay, bond order. We know that bond order BO equals to number of number of bonding electron minus number of anti-bonding electron divided by 2. Number of bonding electron minus number of anti-bonding electron divided by 2. Okay. That means we can write bond order equals to NB minus Na divided by 2. That is the first thing. Second thing, we know that bond length, we can get the information about the bond length. What is bond length? Now we know that bond length inversely proportional to bond order, because with increase in bond order, bond length decreases, and directly proportional to bond length. Okay, and inversely also bond strength, because with increase in bond strength, bond length decreases, and increase in bond order, bond length decreases. So that information we get. Another, we get the information about the homo and LUMO orbital. We get the information about the homo LUMO orbital from the diagram. That is highest occupied molecular orbital and lowest unoccupied molecular orbital. And 4, we can determine the magnetic property of the molecule. Magnetic property. Magnetic property. Where we know that if the number of unpaired electron n not equal to 0, then mu not equal to 0. So paramagnetic. And on the other way, if n equal to 0, then mu equal to 0, it is diamagnetic. So that information we can get from the MO diagram. So from the molecular orbital theory or MO, we can get that 4 information easily. Okay. So now one of the simplest MO. Which is the simplest MO? MO hydrogen molecule. Okay. H2 molecule. H2 means H plus H. H have 1s orbital, 1s1. So we just simply draw one MO and then we will discuss directly. So this is 1s, this is 1s, so this is hydrogen, this is hydrogen, this is bonding, this is anti-bonding. Okay. So 1s1, 1s1, so it is sigma G, it is sigma U. So this is the molecular. So H2 equal to sigma G2, sigma U0. Or you can write sigma 1s2, sigma star 1s0. Whatever you want, you can write. Now bond order, bonding minus anti-bonding. 2 minus 0 by 2, that is equal to 1.0. That is hydrogen has this type of bond. Now question the stability order. Stability order of H2, H2 plus and H2 minus. And according to that, we got that order of bond order. Order of bond order is H21, H2 plus 0.5 and H2 minus also 0.5. So stability should be H2 greater than H2 plus equal to H2 minus. It should be, but it is not happening. So there is exception. So actual stability order is H2 greater than H2 plus greater than H2 minus. Why? Because in H2 minus, one electron is anti-bonding orbital, so unstable. That's why H2 minus is stable among these. Okay. In similar way, we can explain about the helium, why He2 does not exist. Similar way, why He2 does not exist. Then we can see that bond order is 0 because in He2 bond order is 0. So if bond order is 0, that means no HAG bond is formed. That's why He2 does not exist. Monatomic. That we consider each is monatomic. After that, during the drawing of the MO diagram, there is a problem with normal MO. On that time, Coulson MO is appear. For total electronic system, 10 to 14 electron, we have to perform Coulson MO. Coulson MO or mixing MO. What is mixing MO? That means there is a mixing between S and P orbital. We do not know the details about. Someone asked some question, I think. Just a minute. No? ये क्वेश्चन जिज्ञেস করছে বোঝা যাচ্ছে না So Coulson MO or mixing MO, but we do not know. Go to the mixing MO diagram, but we have to remember it. You can remember in a normal way. For MCQ question, you have to just remember that way. Suppose nitrogen, total 14 electron, among them 10 are valence electron, 10 are valence electron. So we can write like K star, then sigma 2s, sigma star 2s. After that, pi 2 py and pi 2 pz, and that's sigma 2 px, sigma 2 px, and after that, pi star 2 py, pi star 2 pz, and then sigma star 2 px. So you have to remember that pi orbital come first and then sigma for nitrogen-like atom, like 10 to 14 electron system. But when you come to the oxygen, then we know that K star, sigma 2s, sigma star 2s, after that sigma 2 px, then pi to py, then pi to pz, and then pi star to py, pi star to pz, and then sigma star to px. So you have see that exchange between these two for oxygen like atom, like oxygen, fluorine, etc. So greater than 14 atomic number or electrons number, then sigma and pi exchange their position. So you have to remember it because in the exam hall you have no time to draw a diagram. That's why you have to remember. So for nitrogen, like 14 electron, so 2, 4, 6, 8, and 10. There are 16, 2, 4, 6, 8, 10, 11, 12. So you see that nitrogen is diamagnetic, no unpaired electron, n equal to 0. So dia. But here you see that n equal to 2. So paramagnetic, oxygen. So now we can say that HOMO. Which is HOMO? Sigma 2px is the HOMO. LUMO is the pi star 2p and pi star 2pz. Similarly, HOMO is the pi star 2p and pi star 2pz, but LUMO is the sigma star 2px. So you can define HOMO, LUMO, all the things by this HOMO diagram easily. Now question is, arrange the following according to bond length order. Arrange the following with bond length order. Like N2, N2 plus, N2 minus, N2 2 plus, N2 2 minus. So now how can we solve it? We know that nitrogen configuration, we know all unknown. So K star, sigma 2s2, sigma star 2s2, pi 2 py2, pi 2 pz2. Just follow my teaching because I am going very fast. Pi star 2 py, pi star 2 pz, and then sigma star 2 px. Okay. So now bond order is bonding minus anti-bonding 2, 4, 6, 8 minus 2 by 2. That is equal to 3.0. So n triple 1 n. You see? Sometimes this configuration you can write as N2 equals to 1 sigma G, 1 sigma U, 2 sigma G, 2 sigma U, then pi U, 3 sigma G, pi G, and T sigma U. You can write that way also. Because you see that K means 1 sigma, first 1 s orbital. K star U. Sigma 2s means G. Sigma star 2s means U. Again pi bonding means U. Sigma 2px means 3 sigma G. Pi star anti-bonding means pi G. And sigma star means 3 sigma G. So that representative also can maybe come in the question, MCQ question. Which is the correct representation for the MO electronic configuration nitrogen atom? There are four options, so you have to choose it. Either that way, sigma 2s, sigma star 2s, otherwise GU that way. When you see the bonding, it is G. When you see the anti-bonding, it is U for sigma. But when pi bonding, it is U. When pi anti-bonding, it is G. You have to remember it, and accordingly you have to solve it. Okay. Next. Okay, next. So N2 bond order is C only. Okay. Now you see that N2 is bond order C. Now N2 plus. If you go to the MO diagram of N2, we will see that sigma 2px is the last orbital which is filled. So N2, you see that a bond order equal to Nb minus Na divided by 2. So for N2 plus what you have observed N2? 8 minus 2 by 2, that is equal to 3.0. So now this is bonding, this is anti-bonding. if you see that N2 plus means one electron lost from the bonding MO. So now it is bonding MO becomes 7, antibody becomes 2, so 2 that is equal to 2.5. Similarly, suppose N2 2 plus means another electron lost from the bonding MO. So now it becomes 6 minus 2 by 2, that is equal to 2.0. Now again N2 minus, so electron enters into the pi star orbital, that is anti-bonding orbital electron increase. So basic is the 8, bonding, anti-bonding 2, there it should be 3 by 2, 2.5. N2 2 minus, that should be bond order equals to 8 minus 4 by 2, that is equal to 2.0. So now we can say that order of bond order N2 greater than N2 plus equal to N2 minus greater than N2 2 plus equal to N2 2 minus. অতএব bond length order inversely proportion, so N2 plus N2 minus N2 2 plus N2 2 minus. So that way you have to solve it on immediate basis. Okay. Now you can similarly explain O2, O2 plus, O2 minus, O2 2 plus and O2 2 minus. You have similarly explain. Okay. Now question, if you see that O2, you see O2, bond order is 2. O2 plus, if you see bond order is 2.5. If you see that plus bond order increases, here plus bond order decreases in nitrogen. You see? So O2 2 plus, if you look onto it, bond order becomes 3.0 because electron loss from the anti-bonding orbital. Electron loss from anti-bonding MO. That's why bond order increases. Okay. So regarding this, there is a question, very important question. Which the question is, I saw that this question is in the West Bengal PSC exam. There is a question in previous West Bengal PSC exam. This question is asked. What is the question? Question is that N2PTF6, okay, cannot form but O2PTF6 form. Why? Then there are 4 options. So among these, which option is correct? Here you see N2 become N2 plus because PTF6 is very strong oxidizing agent, it can oxidize N2 to N2 plus. But here bond order you see decreases from 3 to 2.5. But here in O2 it become O2 plus. So bond order become 2 to 2.5. So here bond order increases, so stability increases. That's why it is formed. So what should be the answer? The bond order increases, so stability increases. Okay. So P6 easily oxidizes O2 to O2 plus due to the increase its bond order. Increase its bond order. That is the stability. Okay. So it is exist. Next question. If someone asks you, okay, I come to that question later. First, we'll discuss different things. Okay. So now O2 is over. So homo for O2. Homo for O2 is very important. That is pi star to py and pi star to pz. So this is one question sometimes asked. This orbital also called sumo. SOMO means SOMO, singly occupied molecular orbital. है single occupied एवं SOMO. So if as it is from O2 plus, that's why it is exists. And PTFC is a very strong oxidizing agent. We know that xenon become Xc plus in presence of PTX6. We know that xenon chemistry. So PTX6 is a very strong oxidizing agent. Okay, very strong oxidizing agent that oxidizes N2 to N2 plus as well as O2 to N2 plus. But this is not formed because due to the stability decreases. As stability increases. Bond order decrease means stability decrease. Bond order increase means stability increase. Okay. So this is the details about the homodiatomic molecular orbital. Now we come to the heterodiatomic molecular orbital, which is also in our syllabus. There are three MO. Okay. Heterodiatomic molecule. Heterodiatomic molecules. There are PO plus CN minus. Just a minute. Just a minute. So these are the one category, another one is HF. So these all have 14 electrons. You see CONO plus and CN minus. So among these, what we can explain it, and this is heterodiatomic molecular molecules. So each have 14 electrons. So if you go to the MO diagram, it is very difficult to draw or you have to remember. So you have to just remember it. CO equals to first, what we have to remember that K star. So 14 electrons, 4 is there. Now 10 electrons are there. Valence shell. So sigma non-bonding of oxygen, then sigma sp1. Okay. Then pi to py, pi to pz have same energy. After that, sigma non-bonding of carbon. After that, pi star to py, pi star to pz, and then sigma sp star. Do not need for sp1. Okay. So electron now 2, 4, 6, 8, 10. So bond order equals to 2, 4, 6 minus 0 by 2, that is equal to 3.0. So that is the carbon monoxide structure is like that. So one non-bonding electron is carbon, another non-bonding electron is in oxygen. Okay. So bond movement towards oxygen atom and lone pair movement towards carbon atom. As a result, mu is very low. Mu low, only 0.3 dB. So why mu is low? Since we know that the CO bond movement and lone pair movement on carbon is mutually cancel each other, partially cancel each other. That's why its mu is very low. Okay. Now, phenomena NO have same. If you go to the NO, that is a 15 electron. Okay, 15 electron having one odd electron. Okay, one odd electron with bond order 2.5. Okay, when NO lose one electron, NO plus, now bond order becomes 3.0. That's why NO easily go to the NO plus, and structure is like similar. O can Okay, so one lone pair on nitrogen, one lone pair on oxygen, it is plus. But before that, how NO looks like? NO looks like this. This is odd electron, and bond order is 2.5. Okay, this is NO. When it loses, then it's become oxygen lone pair overlap here. So positive charge go to the oxygen, and then this is the structure. So cyanide, C triple one N. This is minus, already one lone pair is there. Here also lone pair is there. This is the structure. So all have similar structure. Means isostructural. So CO, NO plus, CN minus, isoelectronic and isostructure and isostructure. So their behavior should be similar. Okay. So for that reason, what we have to need to study that one point is CO is called CO, not only CO, all other things called means cyanide, NO plus, pi acid ligand. What is pi acid ligand? Pi acid ligand. We know that what which are ligand? Ligand have some species which can donate its non-bonding electron pair to the metal are called ligand to form a coordinate bond. What are acids? Acids are the species which can accept lone pair. But why it is pi acid? Because carbon monoxide, NO plus or CN minus can donate the non-bonding electron pair to the metal and simultaneously back accept metal electron to its pi star 2p and pi star 2pz orbital. That's why it is called pi acid ligand. Okay, because you see that carbon monoxide HOMO is sigma non-bonding carbon, and LUMO is the pi star 2py and pi star 2pz. Okay, very simple concept. So now carbon monoxide looks like that. So this is the HOMO, and this is the LUMO. You see, so this is sigma non-bonding of carbon, and this is the pi star 2py and pi star 2pz. Okay, so now what actually happened? Now when metal comes, metal have vacant d orbital. So this is the vacant d orbital. So that donate to the metal vacant d orbital. Okay, to form a metal carbon sigma bond. Okay, when it is sigma bond is takes place, after that, what actually happened? This is step one. So now here CO acts as a ligand. CO as ligand because it can donate its non-bonding electron pair to the metal to form a coordinate one. Then metal have field orbital dxy, dyz or dzx orbital. So now metal have C triple bonded O. So these are the pi star 2pi, pi star 2pz orbital. So metal field orbital donate to the electron to the pi star orbital low energy and then form a that not required. Then form a C now double bond O. This is the driving force and a pi bond. Pi bond. This is sigma. And this pi bond is called dative bond. So here pi acid ligand. Why pi acid ligand? Because pi acid. Why pi acid? Because carbon accept electron pair to its pi orbital. That's why it is pi acid ligand. It is pi orbital. Pi. That's why it is pi acid ligand. It can accept electron pair. Where it accept? It accept to pi orbital. And these phenomena simultaneously. This is step 2. These phenomena simultaneously called synergic effect. Synergic effect. What is synergic effect? Now when a species can donate the non-bonded electron pair to the metal vacant d orbital to form a sigma bond and simultaneously back accept metal field electron to its vacant low energy pi star 2p and pi star 2pz orbital is called synergic effect because sigma bond and pi bonding takes place simultaneously. That's why it is called synergic effect. And in a single diagram you can see it. So this is the symmetry. So sigma as well as pi, both are from simultaneously. Okay. So this is the phenomena of this synergic effect phenomena or ligating behavior of carbon monoxide. So now if someone asks that what will be the pi acidity order, then we can say the pi acidity order NO plus maximum, then CO, then CN minus. Because NO has there is a plus, so driving force for the back accept is maximum, that's why NO plus is maximum pi acidity order compared to the CO. Next question arises that CO and N2 both have 13 electrons. You know that? You all know that CO have 13 electron, N2 have 13 electron. But in N2 in air, how many percent? 78%. But if CO is 0.001%, then we can die. Now why? Question is that why we can die? Both have 13 electron, but if nitrogen is 78%, no problem towards human body or living beings. But if CO is 0.001%, then all can die. So how possible? Because due to the only one reason that carbon monoxide has sigma non-bonding carbon and low energy pi star 2py and pi star 2pj. That's why. So pi star 2p and pi star 2pz that can donate and back accept. That's why it can form a very strong bond with the hemoglobin iron Fe, T double bond O and pi. So sigma as well as pi. So that's why hemoglobin form carboxy hemoglobin, and due to that man can die immediately. Formation of carboxy hemoglobin. But nitrogen has no such sigma non-bonding electron for donation. That's why nitrogen is unreactive towards any metal. This is very important reason that why carbon monoxide is too much toxic. Okay. Now if I go to the MO diagram of HF, this is never be asked in the question. I never saw, but you can remember that way. H and F is a single one. We know fluorine has 3 non-bonding electron pair. Here you can. Oh, sorry. Just a minute. So just you have to remember that 1s orbital of hydrogen mix with 2s and 2p orbital of fluorine to form MOs in HF molecule. Okay, HF fluorine has 3 non-bonding electron pair. Among these, one is sigma non-bonding and other two are why non-warning. Okay, so that you have to remember or nothing. And there is, suppose if you triatomic molecule, then for triatomic molecule, water is important for us. Water. So hemodiagram of water. We all know from the VBT theory, water has like that structure. We know that sp3 hybridized, and there are two lone pairs in the water molecule, that we know. So how water is formed, you have to know about that. Just simple hemodiagram. Just you look into the hemo of water. We know that this is the oxygen atom and this is HA and HB, two hydrogen atom. Okay, you can see that it is HA and it is HB. Okay, so H and HB are there. So one is of H and one is of HB have one electron. And oxygen is more electronegative, so here is 2s of oxygen and here are the 2p of oxygen. Okay, 2p, that is px, py and pz orbital. Okay, so 2s2, 2p4 oxygen, we know that. So now we already know from the valence bond theory that is from sp3 hybridization. So one s of oxygen atom mixed with the 3p orbital to form, this is called psi sp3 is formed already. Now this bond is, we know that from the valence bond theory, s and sp3 sigma, that we already know. So now sp3 can form a sigma bond with s. Okay, so there are two hydrogen, so sp3s is complete. So now it is sigma oxygen to HA and sigma oxygen to HB. Similarly, here sigma star oxygen to HA and sigma star oxygen to HB. You see that 4 to 6 orbital take part, but only 4 MO. So another 2 is the non-bonding MO. So this is sigma non-bonding sp3. Now electron fill up 4 to 6 to 8 electrons. So 2, 4, 6, 8. You see that 2 bonding are there, 2 electron. There are 2 electron and 2 non-bonding electron in sp3 orbital. You see? So valence bond theory matches with the MO theory. So that's why MO theory can easily explain the valence bond theory. So what is the MO diagram of H2O? MO electronic configuration. We can say sigma 2 of Ha and sigma 2 of Hb have same energy. After that, sigma non-bonding sp3 2 and sigma non-bonding of another 2 sp3, or we can fly 4 sp3 and then sigma star O of Ha and sigma star O of Hb. Okay, complete. So the VBT structure exactly correlate with the MOT of water molecule. That is the justification. That why MOT is too important. So it can justify. Okay. So that's all about your molecular orbital theory. That's all about our molecular orbital theory. We have discussed. আমি ক্লাস শুরুর আগে বলেছিলাম যে এটাকে আমাদের 1 ঘন্টার মধ্যে কমপ্লিট করতে হবে। আশা করা যায় 1 ঘন্টার মধ্যে কমপ্লিট করেছি এবং তোমরা বুঝতে পেরেছো, আশা করা যায়। যদি না বুঝতে পেরে থাকে ওরা আমাকে কোশ্চেন করতে পারো। Now let us discuss some questions. I will upload all the notes, that PDF notes, to the WhatsApp group today. Okay. That 43 slides in chemical bonding. So you can ask question. Okay. হ্যাঁ, শোনা যাচ্ছে। Okay. Two nodal plane is it is a pi star orbital. হ্যাঁ, হ্যাঁ, ওইটা বলা হচ্ছে, তার কারণ আমি একটু ডায়াগ্রামটা যদি ড্র করে দেখাই তাহলে বুঝতে ইজি হবে। ওকে, তো আমরা সেখানে আমি একটা পিকচারও দিতে পারি। পিকচারটা দেওয়া যাবে না এই মুহূর্তে, একটু ড্র করে দেখিয়ে দিই। দেখাচ্ছে তো স্লাইডটা? হ্যাঁ, তো এই স্লাইডটা যদি দেখা যাচ্ছে, তো আমি এইখানটাতে একটু দেখিয়ে দিই কিভাবে আমরা পাই যে পাই স্টার অরবিটালে আমাদের দুটো নোডাল প্লেন আছে, তাই না? আমি ওইখানে যখন ওই ফার্স্টেই যখন আমরা দেখছিলাম যে হাউ ক্যান ইউ এক্সপ্লেন দ্যাট বন্ডিং অ্যান্টি বন্ডিং এমও, তো সেখানে আমরা বললাম না যে বাকিগুলোর আমি স্ট্রাকচার ড্র করছি না, তো সেই স্ট্রাকচার ড্র করে আমি একটু দেখাতে পারি কটা নোডাল প্লেন আছে, রাইট? তো সাপোজ এটা এটা স্পিকারটা বন্ধ, মাইক্রোফোনটা বন্ধ করে দাও। Suppose a pi anti-bonding orbital should be formed. So now we can consider this is py orbital plus minus, and this is another plus minus py orbital. Okay. Now this combine together to form a bonding MO. তোমার মাইক্রোফোনটা বন্ধ করে দাও, আওয়াজ আসছে একটু। So same symmetry plus plus minus minus the overlap, and now you see this is the electron density, this is the electron density. Okay. So here only one nodal plane, right? Nodal plane. And this is pi bonding MO. So only one nodal plane, so it is psi u or pi u, whatever you can write. Now when symmetry is different, like two pi orbital combined, suppose this is plus minus pi and this is suppose minus plus, right? So now the MO is formed. How it looks like that way, that and another way. So now it is plus minus, it is minus, sorry, minus plus. Okay, you see. So now this is one nodal plane which already present previously, and another, you see, this is another nodal plane. Okay, so that two nodal plane merge each other, that's why we can say pi anti-bonding here, pi anti-bonding. So it is called psi g or pi g. Understand? So when pi anti-bonding molecular orbital is formed, then we see only two nodal plane. Next question to anyone?
নাইট্রোজেনের ওই জিরাডে আর আনজিরাডে দিয়ে যে ইলেকট্রনিক কনফিগারেশন, ওইটা
একবার এক্সপ্লেন করে দেবো, তাই তো? গুড,
হ্যাঁ হ্যাঁ
ঠিক আছে, একবার এক্সপ্লেন করে দিচ্ছি। যে আমরা যদি নাইট্রোজেনের এমো ডায়াগ্রামে যাই, তাহলে আমরা যেটা দেখি, কারণ এগুলো একদম মানে আমার যেরকম করে করে মুখস্থ হয়ে আছে, সেটা তোমাদেরও একটু আস্তে আস্তে করে এগুলো করে নিতে হবে। তারপর আমরা কি দিলাম, সিগমা 2s, sigma star 2s, after that pi to py, pi to pz, and then sigma to px, pi star to py, pi star to pz, and then sigma star to px. So these are the configuration. So now আমরা কি বললাম আগে, যে আমরা বললাম যে যেখানে আমার সিগমা বন্ডিং হয় সেগুলো সব গেরাডে হয়, আর অ্যান্টি বন্ডিং গুলো হয় কি আনগেরাডে, তাই তো? তাহলে কে স্টারটাকে আমি কেটে দিলাম, আমি কি লিখবো, সিগমা 1s, সিগমা স্টার 1s। তাহলে এটা ফার্স্ট সিগমা, ওই জন্য লিখছি কি 1 সিগমা জি, এটা তো বন্ডিং, বন্ডিং মানে জি। তারপরে কি 1 সিগমা অ্যান্টি বন্ডিং ইউ, এটা 2 সিগমা, সেকেন্ড সিগমা আসছে, তাহলে 2 সিগমা জি, 2 সিগমা ইউ। এবার আমরা বলেছি যে পাই যখন বন্ডিং হয়ে যায়, পাই বন্ডিং হলে কি আনগেরাডে, তাহলে এটাকে পাই ইউ লিখে দিলাম। তারপর এটা কিন্তু সিগমা আবার বন্ডিং, সিগমা বন্ডিং মানে কি, 3 sigma g, pi star মানে pi anti bonding এ কি হলো গ্যারাডে, দেন pi g, এগেইন sigma star means sigma u। কারণ আমি যে কনসেপ্টটা দিয়েছি যে সিগমা যদি বন্ডিং হয় গ্যারাডে, সিগমা অ্যান্টি বন্ডিং হলে আনগ্যারাডে, আর পাই বন্ডিং হলে আনগ্যারাডে, অ্যান্টি বন্ডিং হলে গ্যারাডে। তো সেইভাবে আমরা জাস্ট ছকে ছকে লিখে দিলাম এটা 3 সিগমা ইউ। এটা অনেক ক্ষেত্রে 1 পাই লিখে অসুবিধা নেই। এবারে বোঝা গেছে?
হ্যাঁ, পাইগুলোর ক্ষেত্রে 3টা দেওয়ার দরকার নেই, তাই তো?
না, পাই আমরা কেন করছি এটা দেখ, সিগমা বন্ড কতগুলো হচ্ছে এখানে আমি যদি দেখি, একটা সিগমা বন্ড, দুটো সিগমা বন্ড, তিনটে সিগমা বন্ড। সিগমা তিনটে হচ্ছে না, 1s 2s আবার
হ্যাঁ।
2p। তার জন্য ডিফারেন্ট হলো 1 সিগমা 2 সিগমা 3 সিগমা। আর পাই তো একটাই হচ্ছে, অনলি ওয়ান, দ্যাটস ওয়াই পাই পাই।
আচ্ছা, ঠিক আছে।
পাই বন্ডে যেহেতু নাম্বার অফ পাই বন্ড 1 2 3, দ্যাটস ওয়াই 1 2 3। আর কার কি কোশ্চেন আছে?
আর সিও পাই অ্যাসিড লিখেন ওইটা আরেকবার।
আচ্ছা, সিও কেন পাই আসছিল, আমি প্রিভিয়াস স্লাইডেই চলে যাই, বলে যে ওটা ড্র করার দরকার নেই। এই যে আমরা ফার্স্ট আমরা জানতে হবে যে হোয়াট আর লিগ্যান্ডস। আমরা লিগ্যান্ড কাদের বলি না, ligands are the species which can donate its non-bonding electron pair to the vacant d orbital of metal to form a coordinate bond, তারাই লিগ্যান্ড হয়। কোঅর্ডিনেশন কেমিস্ট্রিতে আমরা পড়েছি। আর অ্যাসিড কাকে বলি না, লুইস অ্যাসিডস আর দ্য অ্যাসিডস হুইচ ক্যান অ্যাকসেপ্ট ইলেকট্রন পেয়ার, তারা হচ্ছে অ্যাসিড। আর যারা ডোনেট করে ইলেকট্রন পেয়ার তারা বেস হয়। তাহলে কার্বন মনোক্সাইডকে কেন আমরা পাই অ্যাসিড লিগ্যান্ড বলছি? কারণ কি দিলাম, কার্বন মনোক্সাইড তার নন বন্ডিং যে ইলেকট্রনটা কার্বনে আছে, যেটা হোমো ডোনেট করছে মেটালের ভ্যাকেন্ট ডি অরবিটালে এইখানটাতে, যে সে কি করছে একটা সিগমা বন্ড তৈরি করলো। তাহলে ডোনেট করে দিলে মানে একটা লিগ্যান্ড। সেকেন্ড কি করছে, ওর যে পাই স্টার টুপি আছে যেটা লুমো, লোয়েস্ট আনঅকুপাইড মলিকুলার অরবিটাল, লো এনার্জি, সে কি করছে মেটালের যে ফিল্ড ইলেকট্রন আছে, মানে মেটালের তো 5টা অরবিটাল dxy dyz dzx dx স্কয়ার মাইনাস s স্কয়ার dz স্কয়ার। তাহলে যে লোয়ার যে অরবিটালগুলো আছে লাইক dxy dyz dzx, তাদের ক্ষেত্রে ফিল্ড ইলেকট্রন আছে। সেই ইলেকট্রনটা আবার কি করছে, ওর পাই স্টার টুপি অ্যাকসেপ্ট করছে। তাহলে এই যে একটা কার্বন মনোক্সাইড সে ডোনেট করে লিগ্যান্ড হচ্ছে, আবার সেই ইলেকট্রন পেয়ার অ্যাকসেপ্টও করতে হবে। তাহলে ইলেকট্রন পেয়ার অ্যাকসেপ্টার মানে কি অ্যাসিড, তার জন্য এটা বলা হচ্ছে একসাথে বাই অ্যাসিড লিগ্যান্ড। এবং এই যে ব্যাক বন্ড এটা বলা হচ্ছে ডেটিভ বন্ড বা পাই বন্ড। অনেক সময় দেয় হুইচ মলিকুল ফর্ম ডেটিভ বন্ড, এমসিকিউ দেয়। তাহলে কার্বন মনোক্সাইড ডেটিভ বন্ড করে। এবং এই ফেনোমেননটা বলে সাইনার্জিক এফেক্ট। দুটো ঘটনা সাইমালটেনিয়াস ঘটছে, মানে সিগমা ডোনার পাই অ্যাকসেপ্টার দুটো একসঙ্গে ঘটছে। একটা না ঘটলে আরেকটা ঘটবে না। মানে যদি সিগমা না ডোনেট করতে হবে তাহলে পাই অ্যাকসেপ্ট কোনোদিনও হবে না। একটা আরেকটার উপর হাইলি ডিপেন্ডেন্ট, দ্যাটস ওয়াই সাইনার্জিক এফেক্ট। বোঝা গেছে তো?
হ্যাঁ, বোঝা গেছে।
এই কেসের এমনটা ড্র করে দেবো, ঠিক আছে, কোনো অসুবিধা নেই, করে দিচ্ছি। এটা আমি নর্মাল বলেছিলাম যে পায়ে, ওখানে পায়ে নন বন্ডিং দুটো হয় আর সিগমাতে নন বন্ডিং একটা হয়, তাই না? খুব সিম্পল এই কেপ, মানে সবচেয়ে সিম্পল। তো যেহেতু হাইড্রোজেন মাত্র 1s, সেই কারণে ড্র করাটা খুব ইজি। যে আমি একদম ডিরেক্ট করে দিচ্ছি, এটা হচ্ছে হাইড্রোজেন আর একটা ফ্লোরিন নিয়ে আমি করে দিচ্ছি। তাহলে এটা হচ্ছে এইচ অ্যাটম, দ্যাট ইজ দ্য ফ্লোরিন অ্যাটম। ওকে, তাহলে হাইড্রোজেনের 1s and fluorine have 2s and 2p valence shell. So this is 2s and this is like 2p. More electronegative electron ta towards the, so 2s to 2p 5 to each correspond. That is the 1s1 hydrogen. Okay. Now you see that if fluorine try to so go to the upper step to bonding with 1s, but it cannot come. And similarly 2p try to lower its energy. So this is called hybrid 1 and this is called hybrid 2. And then mixing take place, pulsar MO, mixing MO. So it mixing here, it mixing. So they form SP. So now the energy gap between these and these are very high. H1 and H2 very high, so they cannot interact. Now one has some energy, so that can bond with the H2. Okay, like that way. ইয়ে তো তিনটা অরবিটাল ছিল, তাহলে একটা অরবিটাল চলে এলো H2 তে, দ্যাট ইজ উই ক্যান সে px। তাহলে এখানটাতে কি হচ্ছে, সিগমা এস আর পি এর ইন্টারাকশন সিগমা এসপি, সিগমা স্টার এসপি হয়ে গেল। এবার এই যে অরবিটালটা ফাঁকা পড়ে সেটা ফাঁকা থাকবে না, এটি হচ্ছে নন বন্ডিং হয়ে যাচ্ছে, দ্যাট ক্যান ফর্ম নন বন্ডিং অরবিটাল। তো নাও সিগমা নন বন্ডিং অফ ফ্লোরিন, And here you see that total AO 1, 2, 3, 4, 5. 5 AO are bonding করে যেটা 1, 2, 3. So another 2 should be as non-bonding. So here, so this is the pi non-bonding of fluorine. Why pi? Because the px, py, and pz, px, py, pz. If px from the sigma, then that should be from pi. That's why pi non-bonding. So now electron fill up 2, 4, total electron number 8, 6, 8. So now the MO diagram of HF become sigma non-bonding of fluorine 2, sigma sp2, pi non-bonding of fluorine 4, and then sigma star sp. So now the bond order is 1, and H and F. Now F have 3 lone pair, this non-bonding and this 2 non-bonding. So I have already written that 1 is sigma non-bonding, 2 is pi non-bonding. Now understand? If you have question, you can ask. So here HOMO we can write, HOMO is the pi non-bonding of fluorine, and LUMO is the sigma star sp, and bond order is the bonding minus anti-bonding. So bonding have 2 minus 0 by 2, that is equal to 1.0. কোশ্চেন আছে আর কিছু বোঝা যাচ্ছে? আর কি হাত তুলে দিন, হ্যান্ড রাইজ করে দিন। হ্যান্ড রাইজ দেখতে পাচ্ছি না কারণ হ্যান্ড রাইজ করে দিন, দেখা যাচ্ছে না তো। আরেকবার হ্যান্ড রাইজ করলে আমি বুঝতে পারবো কে। ওকে, যদি না কোশ্চেন থাকে তাহলে আমরা ক্লাসটি এখানে শেষ করতে পারি। নেক্সট হচ্ছে কাজ কোশ্চেন প্র্যাকটিস করা। তো আমি আগামীকাল বা টুনা গুগল ফর্মে টোটাল চ্যাপ্টার উপর কোশ্চেন একটা দিয়ে দেবো গুগল ফর্মে। তো ইউ হ্যাভ টু অ্যান্সার অল দ্য কোয়েশ্চেন্স as soon as possible. I have put some time bound in the night time, and then you have to solve it and see your score. আর অলরেডি আমাদের পিডিএফ এর সাথেও যে অ্যাপস এর মধ্যে অনেক কোশ্চেন এমসিকিউ আছে, সেগুলো প্র্যাকটিস করতে হবে। আর গুগল ফর্মে যে কোশ্চেনগুলো দেবো তার মধ্যে গত পিএসসি এক্সামে মানে লাস্ট প্রিভিয়াস ইয়ারের কিছু পিএসসি এক্সামের কোশ্চেন ওখানে আছে, ওয়েস্ট বেঙ্গল গভর্নমেন্টের যে পিএসসি এক্সামগুলো হয়। তো তার কিছু কোশ্চেন আমি ওখানে দিয়ে দেবো, কারণ যেহেতু আমি পিএসসির কোশ্চেনগুলোর সময় আমি ছিলাম, ওই সময় বিফোর করোনা, তো ওই সময় কিছু কোশ্চেন যেগুলো হতো সেই কোশ্চেনগুলো আমার কাছে আছে, আমি সেগুলো ওখানে গুগল ফর্মে কালকে কিছু দিব কোশ্চেন। তো সেই কোশ্চেনগুলো একটু প্র্যাকটিস করতে হবে, কারণ ওয়েস্ট বেঙ্গল যে স্কুলের যে পিএসসি এক্সাম, ইভেন কলেজের যে সেট এক্সাম বা কলেজের যে সেট এক্সাম, পিএসসি এক্সাম, কলেজ পিএসসি অ্যাজ ওয়েল স্কুল পিএসসি, এই তিনটে বোর্ডের কোশ্চেন আমার কাছে কিছু আছে। তো সেই কোশ্চেনগুলো আমি চ্যাপ্টার ওয়াইজ যে চ্যাপ্টার যখন পড়াবো সেই অনুযায়ী আমি দিয়ে দেবো, সেগুলো একটু প্র্যাকটিস করে নিতে হবে। আর বাকি তো স্টাডি ম্যাটেরিয়ালের মধ্যে অনেক পিডিএফ ফাইল আছে, ওখানে অনেক কোশ্চেন আছে, সেটা একটু করতে হবে। আর আমার কাছে কিছু পার্টিকুলার সেট আছে, পুরো ফুল সিলেবাস ইনঅর্গানিকটা পড়ানো হোক, তারপরে সেটটা আমরা করবো। আচ্ছা, নেক্সট ক্লাস যেটা আমি বলছি যে ম্যাক্সিমাম চ্যাপ্টারগুলো যেহেতু ক্লাস 11-12 রিলেটেড, সো কেমিক্যাল বন্ডিং দ্য বেসিক পার্ট অফ দ্য কেমিস্ট্রি, দ্যাটস আই ফিনিশড ইট। নেক্সট চ্যাপ্টার আই থিঙ্ক অ্যাটমিক স্ট্রাকচারটা আমি একটু পড়াবো, ওই জায়গাটা পড়াবো, ডি ব্রগলি, হাইসেনবার্গ, শ্রোডিঞ্জার, আইগেন ফাংশন, আইগেন ভ্যালু, রেডিয়াল প্রবাবিলিটি ডিস্ট্রিবিউশন ফাংশন, এই জিনিসগুলো আমি একটু পড়াবো এরপরের ক্লাসে। এইটা হয়ে গেলে নেক্সট আমি চলে যাবো একদম ক্রিস্টাল ফিল্ড থিওরি, মানে কোঅর্ডিনেশন কেমিস্ট্রিতে। কোঅর্ডিনেশন কেমিস্ট্রি, আফটার দ্যাট কালার, ম্যাগনেটিক স্পেকট্রা, দেন অর্গানোমেটালিক, রিঅ্যাকশন মেকানিজম এন্ড বায়োনর্মিক কেমিস্ট্রি, এইগুলো আমাদের পরপর হবে। তো উইদিন জুলাই আশা করছি এই যে জায়গাগুলো বললাম আমি এগুলো লাইভ ক্লাসে কমপ্লিট করবো। আর বাকি যেগুলো লাইভ ক্লাস করছি না, লাইক রেডক্স, অ্যাসিড বেস, পিরিয়ডিক টেবিল বা পি ব্লক, এই জায়গাগুলো আমি রেকর্ডেড ক্লাস অ্যাপে আপলোড করে দেবো। তার কারণ যেগুলো ইম্পর্ট্যান্ট, যেগুলো এইচএস লেভেলে নেই সেগুলোতে আমি লাইভ ক্লাসে যাব, আর যেগুলো এইচএস লেভেলে আছে সেগুলো রেকর্ডেড ক্লাসগুলো অ্যাপে আপলোড করা থাকবে। রেকর্ডেড ক্লাসগুলো তোমরা দেখতে পারো, ওখান থেকে কোশ্চেন তাহলে কোশ্চেন দেখতে পারো। ঠিক আছে? হ্যাঁ হ্যাঁ হ্যাঁ, পুরো কেমিক্যাল ওয়ার্নিং। কাল বা পরশু অ্যাজ ইউ লাইক, জাস্ট আমি কোশ্চেনটা দিয়ে রাখবো, তুমি টাইম একটা বাউন্ড করে দেবো যে 24 আওয়ার্স আছে টাইম দিয়ে রাখো, তার মধ্যে একটা সলভটা করে দিতে হবে। মানে তাহলে গ্রোটা বোঝা যাবে, না হলে ক্লাস করে নেবো, ক্লাস করে নিলে না লাভ হবে না, বেশি টাকা দিয়ে এত খরচা ইয়ে করে ক্লাস হচ্ছে, একটু তো প্র্যাকটিসের মধ্যে আসতে হবে। 30টা মতো কোশ্চেন দিয়ে দেবো, প্র্যাকটিস জাস্ট। সেখান থেকে বুঝতে পারো কার কোথায় অসুবিধা হচ্ছে, হয়তো পড়া বোঝা যাচ্ছে কি যাচ্ছে না। হ্যাঁ, এই ব্যাপারগুলো আছে। তো ঠিক আছে, আমরা ক্লাসটা তাহলে শেষ করি। ওকে, গুড নাইট। তোমরা একটু আমাদের অ্যাপসটার ব্যাপারে একটু সার্কুলেট করো বন্ধু বান্ধবদের মধ্যে, যাতে আরো কিছু আমরা স্টুডেন্ট পাই, সবাই যাতে বেনিফিটেড হয়। এইটাই আমাদের একটাই মানে রিকোয়েস্ট সবাইকে। ঠিক আছে, ওকে, বাই, গুড নাইট।